Hello! This video has been prepared by University of Oulu and the Rolex Innovation Labs to present the machine learning workflow inside the FRACTAL platform. So let's present the process. Basically, what we want to do is to upload a dataset to a data repository like FS, and then to design a two-stage pipeline. The pipeline is based on two different stages. The first one is the train operator, which basically is downloading the data and is using the data to train a machine learning model, which then is saved in MLflow. While the second operator is retrieving the model from MLflow and is using the model to make a prediction on new data. The containers related to this pipeline can be uploaded to Harbor, but what we want to focus on in this demo is how we can create an experiment in kubeflow and how we can run this experiment in kubeflow. So let's have a quick look at the script. This one is the LakeFS script, which is basically getting the data using this API. This one is the MLflow, which is simpler and allows to connect to the MLflow server and to get and store the information. And this is the kubeflow pipeline SDK, but we will describe it later in more details. Our goal is to train a tiny YOLO v3 machine learning model on a kubeflow, but to run a pipeline on kubeflow, we need to convert the Python code into a YAML file in order to upload it to kubeflow. So we need the kubeflow pipeline SDK, KFP, in order to manage kubeflow. And then it will be deployed on the kubeflow server. This is the schema of the training of YOLO v3 on kubeflow. You just train the model by downloading the data and configuring and installing darknet. And then you derive the weights of the network using the provided dataset. When doing the prediction, you use the model stored in MLflow, and you use the network to make inference on the image. You can find an example of the code and configuration on GitHub. This is the kubeflow portal, where you can access all the tool to use kubeflow. And for example, you have notebooks, you have pipelines and experiments. And we start defining the pipeline that we want to run on kubeflow. And we will define it via Python script. So let's open the notebook. Here we have this notebook. I'm connecting to it. It takes a while to connect to the notebook. Okay, so here we have some script already defined. Let's pick this one. So this is the Python script that define the kubeflow pipeline. As you can see, we are importing all the libraries, and then we are defining two different Python function that defines the two different pipeline that we want to import in kubeflow. So here we have the train data function, and then we have the predict data function. The first one is training the model starting from the data, while the second function is using the model stored in MLflow to make prediction on new data. After each of these functions, we need to define the pipeline operator associated with the function. So, for example, after the train data function, we are defining this train operator using this comp func container op function. And this is the object that we will use to define the kubeflow pipeline. The same also here for the predict data function, which is associated with a pred op in the same way. Then after that we have defined all the list of function. We need to define this pipeline object, which is defined in this way using this Python decorator. And we define the parameters that we want to use in our pipeline, and that should be defined as an input of the pipeline. And then we are simply defining the list of operation that should be done in our pipeline. So we have the train operator, which is the first one, and then we have the pred operator, which is executed after the train operator. At last, we are compiling the pipeline using this KFP class, which allows to convert this Python script into a YAML file that will be used to upload the pipeline to kubeflow. So now I can just execute the script, and after a while you will see that a pipeline.yaml file is generated. Here it is, and this file can be used to upload a pipeline to kubeflow. Now we want to use this YAML file to upload a pipeline to kubeflow. So first let's download the YAML file, and then let's go back to the kubeflow portal, where we need to select the pipelines and then upload a new pipeline from here. So here we can choose if you want to create a new pipeline or if you want to create a new version of an existing pipeline. We select the pipeline name, and we upload the YAML file. The pipeline has been created, so it is a simple pipeline consisting of two tasks. One is the train data task, and the other one is the predict data task. And from here we can create a run associated with this pipeline. upload a new version, or create an experiment. With kubeflow, it is possible to create also a flow operators such as if and loops. So let's consider a slightly different scenario where we want to execute different pipelines according to the results of some task in the pipeline. So let's consider this new situation where we have a function that is checking whether a model is available on MLflow. So if a model is already available, then only the prediction is performed. While if there is no model available, the model is trained with the data, and then the prediction is done after the training. To do so, we need to insert a function, check model, that is checking if a model is available on MLflow, and the corresponding kubeflow operator. Then, after the train and the predict function, we need to define the pipeline and to add a conditional operator that that checks, which is the result of the model checking, and is defined to different pipelines according to the results of this check. So here we are calling the check operator, and then we use this condition operator that if the output is a train, then both training and the prediction is performed. While if the output is predicted, then only the prediction is performed. So let's run this second Python code. Okay, the YAML file has been generated, and let's download it, and let's go back to the pipeline to upload the new pipeline. So let's upload the file. Okay, here we can see that we have a more complex diagram where the check model is the root, and then according to the result of the condition returned by check model, we have two different paths. So here we can see the YAML file, and as before, we can create, run version and experiment starting from this pipeline. We can create a new experiment for a kubeflow pipeline. Basically, as it said, we can think of an experiment as a space that contains both the history of all pipelines and their associated runs. So let's create an experiment, and we can add some runs inside the experiment. So we can choose which is the pipeline that we want to add. This one example, and the name of the run, and some description. We can select if the run is a one-off, so it is computed once, or it is a recurring one. In this case, we need to specify the trigger, so it could be periodic or it can be scheduled in other way. Um, we can also define the maximum number of concurrent runs and the date range to be used. We can specify the parameters that were defined for the pipeline. Here we have all the parameters that we have defined before. Here we can specify all the parameters to connect to the repository and to the server, and we can start the run. Okay, here we have a run that has already been set in the correct way, putting all the parameters to their correct value, and we can run it. Here we have the information about which part of the pipeline is computed at the present time. We have the configuration that has set, and here the output will appear when they are available. Okay, here we have a run that has already been set in the correct way, putting all the parameters to their correct value, and we can run it. Here we have the information about which part of the pipeline is computed at the present time. We have the configuration that has set, and here the output will appear when they are available.